I will be talking a little bit about how to use the recently developed auto-reduction configuration tools for POWGEN specifically. So if we go to this ID web interface and further go to the instrument tools and select the POWGEN, and then usually we start from the characterization file population. So those files are basically containing the characterization runs, including the calibration run number and those vanadium, empty container, empty instrument measurements, and so on and so forth. Those are just a plain text file containing all this detailed information, which will be used for reducing the data. So that's the interface that we are going to use for here for populating those tables, as we will see in just a moment. And to get access to the page, we definitely need to log in, and here we can just use the UCAM's account to log in. And once I log in, I can see the page, and as I pointed out on the top, information, which is quite important because we only want to limit the access of this web page to the instrument team, as indicated by the right text on the top, which means only team members, which we have some control in the backend of this web interface to control only the instrument team members of POWGEN can get access to this web page. And once we are in this web page, you can see that we have the table where we can populate those entries, and we, for example, have the selection for the cycles. And in the backend, when I do the implementation, it has access to this POWGEN shared directory, and we know where we are going to put those calibration runs according to their cycles. So I will read in the hard disk to get a list of available cycles there, so that we have the selection menu here, drop-down selection, where we can easily select any of the cycles that's available. And say we have a new cycle, we can definitely put in the new cycle name following some standard convention of putting in the cycle. And if we select an entry from the drop-down menu, the manual input box will be updated automatically. But it's not the other way around, because anything we put in as a new cycle will not be existing. So if we updated something here, it will be considered as something new, which is not available in the drop-down menu. But anyhow, we have the capability to do the configuration or adding in the new cycle. And you can see once we select the new cycle, those drop-down menus concerning about the characterization background input table and also the in-plane table will be updated automatically. And so once we select our cycle, we can then go to the characterization background table. If this is really the one we want to play around with to populate the table or make some modifications, we can just go with it and make changes to the table. Or if we want to make changes to other available characterization files, which again was automatically fetched from the hard drive on the analysis cluster, we can also do the selection there in this drop-down menu as well. And also similarly, as compared to the cycle, we can have the capability to manually input a new characterization file, which is not already existing. And then down below the table, we have some notations about the unit of the quantities involved in the table. So the frequency in hertz and wavelength in angstrom, and those columns, the Van Beck and so on and so forth, are just the run numbers. So in the backend, I have the control over the table. So only, for example, valid input are acceptable by in the input. For example, in this case, the highlighted one, I can only put in the integers. If I type some non-integer characters, they will just not accept it. And down below it, we have little control. So see here down below, we have the submit button. Once we populate the table, either this one or the one down below it, or both, once we hit this button, it will just write the table to the hard drive on the analysis cluster, which I will show later on where it will be written into. But we have the control to whether update this table or not to the hard drive by checking this box. And similarly, we have the checkbox for the bottom table as well, which is for the in-plane characterization information. And the logic is pretty much the same as compared to the top one. We can populate the table, we can do the selection, we can manually input a new table. And we have the notations for the frequencies and wavelengths and so on and so forth, some other quantities involved in the table at the bottom. And once we are happy with all the inputs here, we can then hit submit button to submit the table that we just populated or modified to the analysis cluster. So here, if I click on the submit button, just in a moment, you will see some message popping up indicating that the summation is indeed successful. And if you notice down below, there is a little line saying that now the table is updated, is submitted. This guy, which is myself, will be notified where Slack. So currently I just shooting the message to my own Slack channel by implementing some Slack app in it. So if I go to my Slack channel, you can see the update about the POWGEN characterization tables updating the status. It's indicating someone is making changes and who was making the change. In this case, it's just myself because I was logged in as myself. So if other people log in, it was just indicating that someone else is doing the change. And down below it, we have this new table that was just submitted. So in this Slack message, we know what was actually being submitted to the analysis cluster. And then if we go to the analysis cluster, so here I'm SSH into the analysis cluster. It's the same thing. You log in through the web browser or using Symlink to connect to the analysis cluster. Anyway, you go to this directory, which is the shared POWGEN characterization and calibration runs folder. And here I'm located in the cycle which I was updating. And I do a list of the directory. You see all the files, and if I sort them by time, you can see these bottom two guys are those two that were just updated through this web interface. And if we say identify either of them, you can see the new table, and you can easily compare this table with the Slack message table to tell they are actually the same thing. And that's just whatever the values that we put in the web interface. So that's basically how this characterization configuration table should be used and how it is used. So once we have this characterization table populated, we can then move on to the next stage, probably to go to the POWGEN another configuration page, which is the autoreduction configuration. So here is basically the central control over the auto-reduction on POWGEN. How do we reduce the data? How do we control the parameters concerning the reduction of the data? So conventionally, what we have, if we go back to the analysis cluster, and we go to the shared auto-reduce folder for POWGEN, we have the JSON files controlling the auto-reduction pipeline for POWGEN. And because in this JSON file, it contains some sensitive information, so I won't showcase it here, but anyhow, this guy contains some information or configuration concerning the POWGEN auto-reduction. And further, it will point to some other files which is specific to different sample environments for different cycles. For example, if I go to the 2023 cycle, and you can see various different files that is associated with different sample environments. For example, this guy is the new, I believe, the magnetic sample environment for applying the magnetic field. And here you can see all the relevant files corresponding to specifically this sample environment, the configurations, the characterization runs, the calibration files, all the things and all the parameters concerning the reduction of the data. So that's the thing that is being used for controlling the auto reduction for POWGEN. And for sure, we can go to the analysis cluster using either SSH, like what I'm doing now, to make some edits to the files. Or you can go to the web browser using Symlink, whatever way. But anyhow, that involves some like connection and some manual efforts to make changes to those files, which will have control over the auto reduction pipeline. But actually, we can put it into a dedicated place on the web, which is very easy to access and very error-proofing. That's how this web page is going to be helpful. So basically, what this web interface does is nothing but populating the files that we were just mentioning, those guys, in an easy way. So it's doing nothing else but just making the population of those JSON configuration files easier than before and more error-proofing. And again, I have some important information on the top, and I won't go into all the details to the whole table. And if you are interested in checking out the details of those parameters controlling the auto reduction, the backend engine for doing the data reduction, you can click on this link to go to this mandate documentation, because the SNS auto reduction is the backend engine responsible for doing the data reduction. And you can get a lot of information, detailed information there by clicking on the link. And here we have the selection of the cycle, we have the sample environment, and so on and so forth. Maybe two more things to mention. One is about those guys. So here we list out specific calibration files and the characterization files corresponding to a certain cycle selection and a certain sample environment selection. But here we only see the file name, but actually we can know more about them. For example, the calibration file, if we click on this show button, it will just lead us to this monitor website, giving us some information about what is exactly the diamond measurement that was used to create the calibration file and how the calibration is looking like. So that's about calibration. And for the characterization runs, those two guys, again, it just only shows the file name. But actually, if we click on this show button, it will just show the contents of the characterization files that is being used in this specific case. You can see the information, which is just the table that we were populating in the first section through the web interface, and what we see on the command line interface, which I was showing. So this file contents, it directly is grabbed from there in the terminal that we were just seeing. So that's the background characterization. And similarly, we have the in-plane one. And we click on the show button, it will just show the contents of the file that will be used for doing the data reduction. So that's one thing that I want to mention specifically, some useful functionalities provided in this interface to check the contents of the characterization runs. And if we go to the bottom, again, once we populate the table, usually we can probably just stick around with the default values for all the parameters. Usually just that's just what we are using for reducing the data, but just in some cases, we want to make changes to those information or the parameters. We can do that through the table. And once we are happy with the table, we can hit the submit button again to populate those changes to the central configuration file. And again, we will see the message that's printed out in this web interface. And as the same as before, these changes will be I myself will be notified with this update status on this interface, where it's like. And if we go back to my Slack channel, you can see that down below the update message that I got for the characterization runs update, I got down below for the auto configuration file update as well. So again, it's indicating someone is doing the changing for the POWGEN auto reduction in this case, and who was doing the change, and what has been changed, what the new file looks like. So here on the top is the central configuration file, and down below it is the changes as compared to the old version. So here I was just using Gate because we have set up the Gate version control for this central configuration location, which is this location. That's where everything concerning about the POWGEN autoreduction is being located. And if I execute a Gate status here, it will just tell me which files were changed as compared to the previous record. And if I do a git diff, it will just show me what's the difference in between the current version, the new version, as compared to, again, the last recorded or committed in the Gate terminology version. So basically, it gives us some ideas about what is being changed as compared to the old version. And this message will be sent also to my Slack channel through this my implemented pipeline. So I myself get the notification about who was doing the changes, what has been changed, what's the new version, and so on and so forth. So that's pretty much about it, about both the characterization population file interface and also the auto-reduction population interface for POWGEN. Thank you.